All right, workshop students, let me try another video solution for you. Looks like I printed it kind of small. I hope you can see it there on the screen. But it says here, dynamite is placed inside a rock. So you got this rock and you've got this, piece of dynamite in here. So dynamite is placed in a rock. The explosion blasts the rock into two pieces, which have a mass of 1 kilogram and 3 kilograms. So I'll make the 1 kilogram go shooting left, the 3 kilogram go shooting right. Okay. Right after the explosion, the pieces move in opposite directions. The total kinetic energy of the two pieces, and so maybe I'll put kinetic energy 1 plus kinetic energy 2, is 374 joules. And then the question asked the speed of the 3 kilogram piece. Okay, so keeping in mind here that we have a couple of principles. I guess the easiest one, a couple chapters back, is the kinetic energy. So let me call this 1 and this object 2. So 1/2 m1v1 squared plus 1/2 m2v2 squared is the 374. So that's the energy principle that's going on here in this particular problem, this particular question. Now, the other thing, though, is the momentum. And I like to say then the initial momentum is equal to the final. And so in this case, it would be something like this. The m1 v1 initial plus the m2 v2 initial, then later on would have to equal to m1 v1 final and m2 v2 final. Now this one's maybe a little bit easier than other momentum ones because the initial conditions, I think, kind of indirectly imply 0. They're both not moving. I don't know if that's maybe as clear as it should be. All it says is a piece of dynamite is placed in a rock. And so I'm going to kind of assume it's a big rock. You're trying to, break it in half so you can move it, although 4 kilograms for the total is not that big of a rock. But for whatever reason, there's a rock and probably not moving. It's not moving until the dynamite explodes. So I'm going to go with the idea that both the initial speeds, or they're hooked together, so they have to have the same speed. That's very obvious. And that speed is 0. So the rock's not moving. Then the dynamite explodes, and so mass of the first one is 1, and so that would be the final speed of number 1, and then number 2 has 3, and so if we kind of move the final speed of number 1 to the other side of the equation, we can come to the conclusion that their speeds are opposite. That's what the negative means, and that, of course, that's what was described in the problem, that they go in opposite directions. And of course, conceptually, that's kind of implied because that's what happens here in terms of the conservation of momentum. If they had 0 before, we have to have one go left and one go right. So one that has right is positive momentum, and the one left is negative momentum. And so the two together is still 0 momentum. So that's the momentum piece of it. Now, if we use that information and put it up here, we can then solve this problem. Now, the question, let's just see which one they're asking for. It says the speed of the 3 kilogram piece. All right, so that would be meaning we want to solve this for number 2. So let's go ahead and substitute in the speed of number 1 into here, and then we'd have an equation that only has speed number 2, because when we do a substitution of number 1 into here, number 1 goes away, and we only have number 2's. All right, so I'm going to come up here and put a 1/2, and then I might as well put the mass, m1, and then right here, this is the speed of number 1 squared. I don't know if it would really matter if I put the negative on that side, and then I would have this -3, but either way, you're going to square it. That's why I'm saying it may not matter, because you put the negative in here or not, you square it and it goes away. Okay. Then I have the 1/2 and then times the 3 times the final speed of number 2 squared, again equaling the 374. So now we can begin to simplify this. You'll see that each of these right here have the final speed squared of number 2. This 3 squared is a 9, and half of that is 4.5. So that's what I get from that one. And I'll just factor out the speed number 2 squared. And then this is 1.5 when you take a 3 and divide it by 2. So 4.5, 5, so that's 6 times speed squared, 375. So finally, getting my calculator, I could get the speed. So 374 divided by 6, and now taking the square root of all of that, we're looking at about 7.90 meters per second. And hopefully that agrees here with the answer. Yeah, there it is. It says the correct answer is 7.9. So there it is. Both principles, and those are always harder problems when you've got to keep track of both at the same time. All right, take care.